Smart telescopes have completely changed the way people start exploring the night sky. Just a few years ago, taking a picture of a nebula or a galaxy required expensive gear, complicated software, and a lot of patience. Today, you can just do it from your backyard in just a few minutes with zero astrophotography knowledge and with a telescope that fits in your backpack. Now, there's something for everybody, from budget-friendly options like the ZWO SeeStar line and the Dwarf Lab, all the way to premium systems like the Vaonis Vespera and Selena, the Unistellar Odyssey and Eviscope, and even the high-end Celestron Origin. What they all have in common is this: they come as an all-in-one package. You get the optics, the mount, the camera, the focuser, and a very user-friendly app. Just turn it on, pick a target on your phone or tablet, and in a few minutes you'll be live stacking and capturing your first deep sky image. It's really that easy. Let's take the SeeStar as an example. It's probably the most popular entry point today, and for good reason. It is lightweight, super portable, and produces surprisingly good images for something that's under $500. I've taken quite a few nice pictures with the SeeStar telescopes over time. But what happens after the first few months? Some users may start to feel a little constrained. The field of view is fixed, the resolution is fixed, and if you want to image smaller galaxies or planetary nebulas, you just can't zoom in. So naturally, people start hoping for something more. This is why we keep hearing people talk about the SeeStar S70 and the SeeStar S80, a future model with a better sensor and longer focal length. It is likely coming out eventually, but for now, it is more wishful thinking than anything else. But here's the thing. Every time a new model comes out with better specs, you have to upgrade the whole unit. All the components are integrated, so if the sensor gets better or the lens changes, you can't just swap out one part, you start over. So some of you might be wondering, should I move to a more traditional modular setup instead? And then reality hits, because the idea of building a rig from scratch sounds scary. You imagine thousands of dollars in gear, 10 different cables, apps that crash, mounts that drift, software you don't understand, and images that take days to process, if you even manage to get one at all. But what if I told you that's really not the case anymore? What if I told you that you can build a traditional imaging setup that behaves almost exactly like a smart telescope? The same ease of use, the same wireless control, the same tap-to-image experience with way more flexibility. Today, I'll show you exactly how I did it. A small, powerful rig made from separate components, but working together, just like a SeeStar, only better. I promise it is way easier than it looks. Let's get started. My name is Lucia, and you're watching the Space Koala. And now, before we dive into the build itself, I want to be clear about one thing. This here is not the cheapest possible setup. Every component I chose here was picked to make life easier, not harder. Because let's be honest, if you're moving from something like a SeeStar, the last thing you want is to suddenly deal with balancing issues, a cable spaghetti, or crashing software. So let's tackle those one by one. First, the mount. If you used a traditional equatorial mount before, you know that typically you need counterweights and careful balancing. Here I'm using the ZWO AM3 harmonic drive mount, and with lightweight setups like this, you really don't need any counterweights at all. You just attach the telescope, polar lined, and you're ready to go. No balancing required. And then let's talk about the telescope itself. This is the SeeStar V. It's one of the most versatile refractors out there, and that is exactly why I chose it for this build. You're not locked into a single focal length like with a smart telescope. Instead, the SeeStar V lets you swap between different optical configurations just by changing the lens or using accessories like the reducer, the flattener, or the extender. With the 60mm module and reducer, you can go super wide, 270 millimeters, perfect for large nebulae or star fields. With the 80 millimeter lens and the extender, on the other hand, you can reach up to 600 millimeters of focal length, ideal for galaxies or smaller deep sky objects. And the best part, you're using the same camera the whole time. Just swap out the front section or one of the flattening elements and you've got a completely different setup. So this scope gives you 6 different fields of view in one system without needing to change mounts or cameras. That is flexibility you simply don't get in any of the all-in-one smart telescopes. Next, the cables, or better said, the lack thereof. This is the ASI 585MC Air, and it is the heart or brains of the setup. It is a cooled color camera, yes, and it also has the ASI Air hardware built right in. So there's no need for a separate controller, no USB hubs, no extra mess. If you want to know more, I did a whole video on this camera and I'll link that in the description below. And this whole thing connects to your phone or tablet wirelessly. And here's the bonus. This camera also includes a built-in guide sensor. And this is something you don't get on almost any smart telescopes today. That guide sensor lets you run longer exposures reliably because the mount can make corrections in real time. That means cleaner subs, fewer rejected frames, and if you want to process the images yourself, fewer files to handle in Serial or PixInsight. I've also added a ZWO EAF Pro for autofocus. It runs on a rechargeable battery and connects via Bluetooth. So again, no extra cables and no external power needed. The focus routines are all handled by the app automatically, so it just works. So what you're seeing here is a completely cable minimized, wireless, tightly integrated system where all the components speak the same language. Now I know some of you are thinking there are cheaper alternatives to all of this on AliExpress. And yes, this is completely true. There are more affordable alternatives. There are small harmonic mounts, cameras that cost less, and even ASI Air alternatives. You could use them, but be aware that they will likely not integrate as seamlessly as this system does. You might need to install your own drivers, troubleshoot compatibility issues, or just deal with apps that don't support every feature. They're fine if you enjoy tinkering, but they're rarely as seamless as you may be used to if you're coming from the world of smart telescopes. This setup here is about maximum simplicity. With full control and flexibility, it is a setup that behaves very similar to a smart telescope, but with room to grow. You can upgrade the optics, you can swap the camera, you can add filters, rotators, mono sensors, or higher-end mounts. Or you can just leave it as is and enjoy the convenience of point-and-shoot astrophotography, but with better resolution, longer exposures, and more flexibility than a sealed system can ever offer. Next up, I'll show you how easy it is to set it up and take you from powered off to imaging. All right, let me show you how simple this setup really is to use in practice. One of the nicest things about this setup is that most of the components stay together in one piece. The focuser, the camera, the adapters, they all stay connected to the telescope. So all I have to do now is put the scope on the mount, polar aligned, and I'm good to go. This makes the setup super fast. There is no balancing required thanks to the harmonic mount, and there are no cables to untangle. It is genuinely just mount, align, shoot. So let's do it. Let's power everything on and connect. I'm powering everything from this small portable power station with the ASI 585MC Air being the brains of the operation. It handles the control and powering of the camera, the focuser, and the mount, all wirelessly. Once it's powered up, the ASI Air app on your phone should automatically detect all the devices, but just in case, here's how to check everything going through the icons at the top menu bar. Go into the main camera and select the 585 Air. If you want to use guiding later, you can also add the built-in guide sensor in the guide menu. For the mount, I'm using the AM5, and here I've connected it via Bluetooth. Under Focuser, I select the EAF Pro, also connected by Bluetooth. This all takes literally under a minute, and once it's done, we're ready for polar alignment. First, from the preview screen, I make sure that I have visible stars in the field, otherwise we may need to adjust initial focus. As long as I can see some stars, I go to the polar alignment tool by clicking preview and selecting PA. Here, the telescope takes a picture, rotates by 60 degrees, takes another picture, and calculates how far off perfect polar alignment I am. In my case, tonight, I'm a little bit off both in azimuth and in altitude. So now I just have to use the knobs on the mount to make those adjustments. This is no different from what you're already used to if you're using the SeeStar or the Dwarf in equatorial mode. You can also choose to enable auto refresh, which will keep updating as you tweak the alignment, or refresh manually when you're ready. Once the polar alignment error is below a certain threshold and you see the little guy on the screen is happy, you're done. Let's pick a target. I have a very nice open southern horizon tonight, so I'll go for something far down in Sagittarius, the Trifid Nebula. Once I selected my target, I hit Go To, and the mount will smoother and plate solve and fine-tune the position. Once I'm on my target, I can adjust my framing in the Sky Atlas, including fine-tuning the rotation too. For example, I know that I want the Trifid to be in this direction in my picture. The ASI Air immediately tells me I have to rotate my camera by this many degrees. Once we are on the target and happy with the framing, let's start imaging. I will select the live option from the shooting menu. If this is the first time we're using the device for live stacking, we want to create calibration frames, just like smart telescopes do behind the scenes. Let's start with bias frames. I'll take 30 of them. I choose very short exposure times, and of course I cover the front of the telescope completely to ensure no light gets through. I will click start, and it will quickly take all 30 frames and then start stacking them immediately. A few seconds later, it tells me that the stacking was successful and we now have a master bias frame we can use. Keep in mind, you only have to do this once. Once the bias frames are done, we move on to flats. Flats are the most essential calibration frames. We use them to correct any type of unevenness in the picture by providing a reference frame, the flat frame, that we know should be a completely uniform image. To do this, I'm using a white light panel here, but you can use your tablet, you can use your computer screen, or even daytime sky. Again, I'll take 30 flats. ASI Air will automatically combine them into a master flat frame, and it will let us know as soon as it's done. What is left? Dark frames? You can take them if you want, but for this sensor, honestly, they're not really necessary. The ASI 585 has no amplifier glow, so I think we're good to go. All right, now that we're polar aligned and calibrated, we actually start imaging. I select lights, and for now I set this to 120 seconds. And I will also open up the guiding window, and I will literally just click on calibrate, and it will start guiding for me automatically. If you don't want to use guiding just yet, maybe it's a good idea to pick a shorter exposure time, like maybe 20 to 30 seconds, just to be sure you don't have any trailing, and that is something you are familiar with already from the SeeStar. 20 to 30 seconds should be short enough that guiding is not necessary at these focal lengths, and those short exposures are also a good balance. Long enough to get clean signal, but short enough to avoid star trailing if something is not perfect after all. If you have a motorized focuser like mine, you can also enable refocusing during live stacking, ensuring that your stars will stay sharp all night. At the bottom here, you can enable saving all individual frames for later processing. I highly recommend you do this if you think you will reprocess your data later in serial, PixInsight, or even directly on the ASI Air. I select the flat and bias calibration frames that I would like to use in this session, and I simply browse the file systems for the master flat and master bias that we have just generated. At the stack duration, I can also set a limit of how long I want the live stacking to go for, and once we're all done, we save the settings. Now, we let it run, and as the frames stack, we see the Trifid nebula slowly start to appear. We can zoom in, we can stretch the image on the fly to our liking, and watch the photo come to life in real time. And that's it, a full smart telescope experience, but using dedicated astrophotography gear that you can grow together with. Good morning. Let's take a look at the images I captured and also break down what this setup really costs and how that cost compares to a SeeStar or other smart telescope. Alright, so here's what I got from just one evening of imaging with this setup. Keep in mind that it is currently summer solstice time, so all night really means just like 2 hours for me. This is the image that came straight out of the ASI Air, and I just saved it on my phone. Not bad, right? Let's take a look at the images we captured. Since we enabled the option to save all individual exposures, you'll find all the light frames stored in the lights folder. Alongside those, you'll also find the master flat, the master bias files saved in their respective folders. If you had taken darks, those would also appear in a separate darks folder. At the bottom of the lights folder, you'll also find the stacked image that the ASI Air created during the live stack. Afterwards, post-processing the file, this is what the final result looks like. The whole process was super simple. The system just did its thing, live stacking the photos, refocusing when needed, and I think that's the key takeaway. This setup behaves almost exactly like a smart telescope, but with way more power under the hood. So the elephant in the room, let's talk about the price. The SeeStar 50 costs around $600. The SeeStar S70 is even less, around $400. You can calculate another $100 for accessories such as the EQ wedge on a tripod, and another $100 for a power bank if you plan to run it all night. This rig, a lot more. The SRV telescope will set you back anywhere between $1,000 and $1,800, depending on the current promotions, and lately there have been quite a few good deals on it. The ZWO AM3 mount with the tripod goes for around $1,500 to $1,800. The ASI 585MC Air camera is about $800. The EAF Pro focuser adds another $250. And finally, a solid power station that can run your whole rig comfortably through a long night will cost you around $300. So all in, you're looking at least $4,000, including power. So yeah, you could buy 8 to 10 SeeStars for the price of this, or you could almost buy one of the more expensive smart telescopes like the Celestron Origin. But here's the difference. With this setup, you're getting versatile optics, a higher resolution cooled sensor, the ability to take longer exposures with guiding, and a fully modular system that can grow with you as your skills and interests evolve. On the other hand, the ease of use is remarkably similar to that of smart telescopes. The app experience is just as smooth, the automation is there, and you're not limited by a fixed field of view. That said, $4,000 to $5,000 is a lot, but luckily there are plenty of ways to scale this down. There's always a trade-off in ease of use, but I do have a few specific suggestions that will cut down on the price and still keep the rig relatively easy to use. Number one, use a more affordable refractor. Especially if you don't need the swappable modules, you can save a lot. The SRV offers a great cost to quality ratio, but if modularity isn't important to you, you can spend less than half of what this telescope costs. Number two, skip the motorized focuser. I say this in pretty much every video about small refractors. If you're okay with manually setting the focus at the start, an autofocuser really isn't necessary unless you're planning to swap filters. These scopes are compact enough that focus usually holds well throughout the night, even if the temperature drops. Number three, go for a simpler mount. You can use a more budget-friendly star tracker like the Skywatcher Star Adventure GTI, which can still handle this kind of setup well if you keep it lightweight. And number 4, choose a cheaper camera. A big cost saver is to stick with an uncooled camera or use one of the more affordable non-air ZWO models together with a separate ASI Air Mini. This still gives you access to the whole ZWO ecosystem, just at a lower price point. For example, if we switch to the 71F flat field refractor, drop the focus motor and switch to a Star Adventure GTI, the total cost drops to under $2,000, a significant portion of which is the camera system. You could shave down maybe $200 from this by skipping the cooled camera and getting a small planetary camera with a separate ASI Air Mini, but I personally would not recommend that. You'd also miss out on the possibility of guiding and the nice larger field of view for only very modest savings. You kind of have to think about how much of this all-in-one convenience you're willing to give up for an even more affordable rig, while keeping in mind also how much you'll likely want to be growing in this hobby in the future. A better choice of rig today ensures you'll spend overall less over time. Of course, you can also go in the opposite direction. You could pair this exact rig with something like the ASI 2600 MC Air, which gives you a much larger field of view, higher resolution, and the same wireless integrated experience, just at a higher level. And that's the beauty of modular systems. You can tune them up or down depending on your goals, your budget, and how serious you want to get. So should everyone ditch their smart telescope and build up a setup like this? Not necessarily. If you're happy with your SeeStar, your Stellina, your Vespera, whatever, awesome, keep using it. But if you're starting to outgrow it, or just want more flexibility, this kind of modular system is absolutely worth looking into. And as you've seen it last night, it doesn't have to be difficult. You can build something that's still beginner-friendly, wireless, super clean, and capable of serious results. Keeping the same simple app-based experience, but adding way more options. So whether you're upgrading from a smart scope or you just want a rig that gives you room to grow, a setup like this is a great place to start. And who knows, maybe your next deep sky masterpiece will be taken on something that you built yourself. I will link every product that I mentioned in the video below, organized by the price range to let you find your rig easier. If you've enjoyed this video, don't forget to subscribe to the channel to support my work, and thank you very much for watching. I wish you clear skies.